Is analog output with the National Instruments USB-6211. The 6211 has two analog output channels capable of 16 bits of accuracy and 250 kilosamples per second. So in our setup today, we have our two analog output channels connected up to two LEDs. Analog output channel 0 is powering the green LED, and analog output channel 1 is powering the yellow LED. The third line here is ground coming up common to both LEDs. I'll also note that these LEDs have a resistor built in to limit the current output from the analog outputs. So now let's go ahead into LabVIEW, our graphical programming language, and program up this task. On our front panel, we'll click the right mouse button and we'll put down a waveform graph. We'll stretch this out a bit so that you can see it. And we'll also stretch the legend so that you can see that we have multiple channels. We'll click right on the trace and we'll change the color. We'll actually change these colors to match the colors of our LEDs. We'll increase the line width so that you can see it, and that will set up the traces on the waveform graph. So that sets everything up. Let's go back to the diagram now and begin to program. We're going to combine a couple analog waveforms and output them out our analog output channels. So we actually have to go and create those waveforms. So we'll click right, we'll go into our Express VIs, and we're going to choose Simulate Signal. So we'll put that down, and the first thing that we're going to do is choose a sawtooth waveform, and we're going to actually just use the first part of it because we want to create a ramp. So in this case, I'll set a frequency of 1, an amplitude of 5. We'll tell it 6,000 samples per second, and we'll give it a total number of 3,000 samples. We also want to just reset the phase so that this doesn't change every time as the signal is running. So we'll say OK to that, and that creates, in this case, a sawtooth, but it's only a partial sawtooth, or a ramp. We'd like to create another waveform now, and in this case we'll do the same thing. We'll simulate signal, and we're going to generate a sine wave. Now when this comes up, it already defaults to sine, so we're all set there. We're going to give it a frequency of 9. We'll give it a phase of 90. We'll give it an amplitude and an offset both of 2.5. Again, we'll tell it 6,000 samples per second here, and we'll output a total number of 3,000 samples as well. We're going to tell it to reset the phase each time. We'll click OK, and now I have the two waveforms that I would like to put together. The way that we put this together is through an append function. So we'll click right, and we've got a nice Express VI that can append signals together. So we'll go and select that function, we'll put it down, and we're going to combine the waveforms now. We want to deselect this append if T0 and TDT match, because we want them to just connect up regardless of the start times. So now we'll take the sawtooth and we'll wire that in, and that's our first signal that goes in. We'll take our sine wave and wire that in, and that's our second, and that's all set up and ready to go. Now I'd like to create a second waveform by just appending the signals in reverse. So we'll go down and get another append function. Again, we'll deselect the append only if aspect, and we'll click OK. And now we're going to wire in the signals, but we'll do that in just the reverse order. So our first waveform in is the sine wave, and then coming down from the top is our ramp or our partial sawtooth. And now we're ready to go with that. What we'd like to do next is do our analog output. So we're going to click the right mouse button. We're going to go down and choose our DAC assistant that will help us set up our analog output task. So we'll drop that down, and we're going to choose Generate Signals, Analog Output, and a voltage. And then we'll choose both channels because we're going to output our waveforms on both channels simultaneously. So we want to tell it to generate continuous samples, and then we're going to set our own output rates now of 3,000 samples per second, and then 3,000 samples total, and we're all set there. We'll click OK, and then we're set up with our analog output. Now what we need to do, it's going to ask us if we want to put this inside of a loop, and we'll tell it yes, because this will run over and over again. And we're ready to begin to wire up our output signals. The first thing we'll do is we'll take our first signal, and we'll write it out to our waveform graph, and this is going to allow us to see it on the front panel. We'll take that second signal that we generated and we'll put it out to our same waveform graph, and you'll see that it goes and it creates a bundle. It bundles these together so that we can see that better. Now we're going to take that same combined set of waveforms, or that bundle of waveforms, and we're going to wire that right into our analog output task. So we'll click on that and we'll wire it right up to our analog output. At this point, our program is complete and it's ready to go. So we're going to go back to our front panel. We're going to click the Run button. We'll see our waveform generated. And now you can see on the front panel that our green waveform oscillates and then it ramps up slowly. And just the opposite of that, the yellow waveform will actually ramp up slowly and then oscillate afterwards. So as it's driving these analog output waveforms out our analog output channels, we can see that the green light blinks right here and then it ramps up slowly, and it does that just out of phase with the yellow LED that's now ramping up slowly and now blinking, ramping up and blinking again. So this is at 3,000 samples per second per channel analog output, and it's an example of how you do analog output with the USB-6211.